Welcome to an exploration of one of quantum mechanics' most intriguing concepts, the wave packet, nature's very own postal service. The quantum world is not made of tiny billiard balls, but of probability and waves. Understanding how particles move requires a new perspective. How do we represent a particle that acts like a spread-out wave but behaves like a single point of matter? That is our primary challenge. The solution is the wave packet, a clever mathematical construct that bundles waves together into a localized pulse of energy. At its core, a wave packet is a superposition of many individual waves of different frequencies, interference patterns working in harmony. By layering different frequencies, we create a wave that doesn't span infinitely, but instead concentrates its intensity in one specific region. Through constructive interference, these waves amplify each other in the center, while destructive interference cancels them out everywhere else. Think of this as a postal package. Just as a box holds contents in one place during transit, a wave packet contains quantum information. This package allows the particle to exist as a coherent bundle of energy, effectively defining where the quote mail is at any given moment. Within this bundle, the packet carries both the approximate position and the momentum, acting as a courier for quantum properties. But how does this packet travel? It moves through space as a single unit, keeping its identity as it propagates. As long as it remains coherent, the packet maintains its shape, acting like a solid object moving across the quantum landscape. However, nature is fickle. Over time, these packets inevitably spread out, a phenomenon known as dispersion, where the bundle slowly loses its definition. Let's look at the mechanics behind how these individual waves weave together to form the structure of our quantum delivery system. This animation shows the superposition in real time. Individually, these waves are infinite, but together, they create a sharp, moving pulse. The edges of the packet represent the bounds of our knowledge. Where the packet fades, the probability of finding the particle vanishes. This brings us to Heisenberg. The tighter we make the packet to define its position, the more spread out the underlying waves must become. This creates a fundamental trade-off. We can know the position well, or the momentum, but never both with infinite precision. A well-defined packet implies a wide spread of momentum, the price we pay for localizing the particle in space. Wave packets are the very language of the quantum world. They represent the compromise nature makes between being a wave and being a particle. Ultimately, the packet is the fundamental language of quantum particles, summarizing their state into a manageable, measurable form. Understanding wave packets helps us grasp how matter moves, shifts, and interacts across the universe. Thank you for joining this quantum journey.